Hello, this is Elizabeth Pluswick, and this video is going to go over the strategy and solution for solving demonstration problem 15.30 from the back of the Engineering Economics handout. We did this problem also in class the week of November 18th, 19th, around in there, but if you missed it, here it is again. The question asked, what is the equivalent uniform annual cost for a machine with initial cost of $80,000? They estimate they can sell it at the end of its life for $20,000 cash in salvage value. The machine has annual operating costs of $18,000 for each of the 20 years of the asset's life. The interest rate is 10%, and again the question is, what is the equivalent uniform annual cost for the machine? Now, to solve a problem with equivalent uniform annual cost or equivalent uniform annual benefit, the word annual is the operative word, and that means the average annual cost. In other words, find A. Turn all of the cash flows into an annuity, and that annuity will be the average annual cost or average annual benefit of using that machine over its entire lifetime, including all the cash flows, whether in or out, over the project's entire life, basically just averaging them out and coming up with a uniform annual amount, and that is A, annuity. So for this example, the timeline would look something like this for problem 30, the back of our handout. Initial cost of $80,000, that's in terms of P, right? Present value. $18,000 annual operating cost every year for 20 years. That is already in terms of A, right? We want to take all of our cash flows and put them equivalent to A, put them in terms of A. This cash flow that happens once a year for 20 years is already an annuity. And then our other cash flow in this project is $20,000 anticipated cash flow in the future. So it's in terms of F right now. It's a future cash flow for the salvage value, what we think we can sell that machine for at the end of its useful life. The appropriate interest rate, discount rate for this problem is 10%. We want to turn everything, all those cash flows, into terms of A, equal uniform annual cost. So we just take our cash flows and decide, is it already in terms of what we want, or do we need to multiply it by a factor from the interest tables in order to turn it into the terms of what we want? In this case, we're looking to turn everything into an annuity, equal uniform annual cost, or if it was benefit, we're saying find A, basically find A. So we have this first cash flow, $80,000. We want to find A. Given what? It's given in terms of P. Interest rate of 10%, 20 years. So we take $80,000 cash flow and multiply it by a factor from the 10% interest table in the AP column down on the 20-year line. Our next cash flow is $18,000. It's already in terms of A, so we do not need to multiply that amount by any factor. We have one more cash flow in the problem, and that is the future $20,000, future cash flow. We want to find A, given that is already in terms of future, so we want to find A given F, 10%, 20-year life, 20-year term. Okay, so we'd find a factor off the 10% interest table in the AF column on the 20-year line, take that factor and multiply it by $20,000. Now I'm going to take a moment to talk about the sign here. $80,000 and $18,000 are both costs. I've treated them as a positive number here, but they're cash outflows. Why wouldn't I put a negative? Well, I could have put a negative. I could call that negative 80,000 minus, 18,000 cash outflow. and then this one I would have to treat as a positive because it's cash in. The point is to be consistent. This is a cost, I'm calling it positive number. This is a cost, I'm calling it a positive number. This is a cash in, a benefit, so I change sign because it's the opposite direction of cash flow from these two cash flows. Could be negative, negative plus 20,000, as long as the benefits are all treated the same way, or the benefits are all treated the same with the same sign, and the costs are all treated with the same sign. It doesn't matter which way I go, I'm still going to get the same answer. So next I've just looked at the interest tables and found the appropriate factor to multiply by each relevant cash flow. Again, no translation necessary on this one because it already is in terms of an annuity. And then just do the algebra and solve. And the equal uniform annual cost is $27,050, or answer choice D. Asking back, does that make sense? Is that reasonable? 27,000 seems reasonable because we're looking for a annuity, and we already have an annuity cash outflow of 18,000. So we're basically taking this initial fairly large cost and spreading it over the 20-year life, taking this future proceeds in and spreading it back over the 20-year life. So it seems reasonable that our average annual operating cost would be something more than 18,000, and here it actually worked out to 27,000. That's the average annual cost to operate that machine, given its initial cost, its future salvage value, and all the operating costs for the 20 years in between. So that's the strategy in solution for problem 1530.